Hi, and welcome to the final third-person camera tutorial in Unity. In this last tutorial, we're going to be working on our camera and adding the last feature. So far we worked on the behind-the-back camera, a targeting camera where it would stick behind the character, a first-person camera, the ability to have collision against walls, and we've got one more thing to work on, which is the free camera. And what the free camera is in a lot of the third-person Nintendo games, if you hold back on the stick, you can free the camera and push it out. And this camera will intersect with the walls, and you'll be able to run with the character in reference to the direction of the camera. So if I hold right, Link will run right. If I hold left, he runs left, forward, backwards. I can rotate the camera while I'm doing this. It's just an easy way to position the camera in an exact spot if you're trying to do something like looking around a corner or something like that. So you can kind of look over things, and I can see those guys over there. So that's what we'll be doing in this lesson. Open up our script. The last tutorial, for this one, we're going to be adding a final mode to our camera. And you can see that in our struct that we had this one called free. So this will be the last one we add. And to do that, we're going to need to add some new variables to our class. The first one we're going to add is a distance away multiplier and a distance up multiplier. And what these are is when you're pulling back on the stick, we need some limit to how far back you can pull and how close up you can go. So this is going to be basically the way that we figure out how high you can go and how far back you can go. The next thing we're going to do is we're going to add in a variable for a threshold on the stick. So we're going to have this threshold variable, and that's going to be a variable that says if I pull back X amount on the stick, that's when I want the camera to go into this free mode. So we had the same idea for the first person mode, but that was actually pushing up on the stick. So we'll go with that. The next thing we want to add is 3 more variables. And these are the minimum distance from the camera, so that's how close you can go to the character. So that would be moving up really close, probably about that far, and we want a variable in X and Y. So it's going to be the minimum distance in terms of X and in terms of Y. Height and closeness, I guess, are better terms for that. And then the last variable we want to add is actually four more variables. We want to have a saved rig to goal, so we want to save the distance that the character is from the camera. So when we aren't holding the stick, we know how far to position the camera, because we need to keep updating that on every frame. So we want to save that distance. The next one is a distance up free and a distance away free. And that's going to be save rig to goal, you can think of as the direction that the camera is in, like the vector direction that the camera's in. And distance up and away are the actual closeness in terms of height and in terms of distance from the character. And then the last one, we're going to be saving the previous frame's stick variables, because we want to have it, we want to only move the camera back if the new direction is further. So the idea here is if we push the camera all the way back, as soon as we push the camera back again, since this value is less than the previous stick's value, we don't want to move the camera until we get all the way back again. So that's the last variable. Okay, so let's start adding some logic at this point. First thing we want to do is we want to add in a little bit, something that doesn't seem quite right, but we want to reset the target position every frame. And the reason that we want to do this is because in our camera script, if our target position doesn't change, like the distance away and the distance above, then we don't want to if it doesn't change, we don't want to move the camera from where it's currently sitting. So we need some way of recognizing if that target position didn't change and to use the previous calculations for the target distance. So this is just going to reset it every frame, and we can do a check for if target position equals vector 3.0. Next thing we need to do is we need to add in some logic for actually transitioning into this case. So this here is going to be the third person free camera case. And the condition here is going to be if the right X stick is less than the threshold, and if, because we're moving back on the stick, and if the speed is 0. or is rounds down to 0. And then we also want to add a condition to our entrance into the first person mode. And basically just want to say that we don't want to go into first person if we're in third person. So that means if we got this camera mode, when we push up on the stick, it shouldn't enter into first person. So we need to tell the script that that's a case. So that's it for that logic. Let's go ahead and save the script and see if we get any errors. So no errors. We got a lot of unused variables, which makes pretty good sense. Let's add a new case in here, and we'll just check and make sure that we're actually registering this camera behavior. So we're just going to add a new case to our switch statement, and it's just going to say if the camera state is in free state. Okay, add the break statement, and we'll just add a debug statement in there just to check. So hopefully this will compile. And let's run it. So all good, everything still works. We can still go into our free mode. Now we're in our so now we're in the free mode, which we just set target position equal to vector 3.0. So this behavior makes sense. Our camera's just sitting at the origin. And if we snap back, it stops giving that debug log. So it looks like our conditions are good. I think that is good enough there. So next thing we want to do is go back to our script, and we want to add actual logic for what to do when we're in this state. We're going to start with how we're going to move the camera. We want to move the camera, we want to get the direction from the camera to the character. And we also want to reset the look weight. We can't actually call reset camera. If you notice in everything but first person, we've been calling this reset camera method. We can't do that here because reset camera is going to change the local rotation of our camera. And since we're going to be moving our camera around in this third person mode, we need to have control over the rotation. So we can't do that. Instead, we're just going to call basically the first line of this method, and we're just going to put that here. So that's what this line means. Next, we're going to calculate the rig to goal direction, which is just the distance from the character's head to our camera. So if you look in Unity, all that is just minimize this and get our character. So rig to goal is just going to be the direction between, it's just the vector subtraction of our character and our camera. And we're going to normalize that to make it sure it's a direction, and we're going to set the y value equal to 0 because we don't want any y rotation in that direction. We just want it in terms of x and z. And then rig to goal is almost the same thing, but we're actually using the parent rig. So if you remember in a previous lesson, we made this camera rig object, and it may not seem exactly intuitive what the purpose of this is, but the idea is pretty simple. It's like creating a camera that they would make in Hollywood or something. We want to have control over. So if we've got our camera here, let's see here, tab. Photoshop doesn't seem to be working. So sorry about that. It appears Photoshop gave up on trying to work. So basically the idea of this camera rig is that we want to have something, a secondary object that we can rotate the camera within. So if you're just trying to rotate the camera, we want to have this object that can move around the character. So we want this thing to kind of position itself somewhere around the character. And then the actual camera will always look at the character. And then we want to have it be able to just move in this direction. So you can think of it like kind of this ball and socket joint. Like think of the camera, this camera piece here as this part of the camera, and think of this just plain game object as this dolly. So the dolly is going to rotate in a circle around our character, and then we're just going to have the camera that can kind of position itself. So it's a pretty simple idea. Hopefully that makes sense. And what we're going to do with that is we're going to figure out the distance from the rig to the goal, And this is different from this because we're not actually finding direction here. We're just calculating a ray here, just so you can see what that looks like. So we're gonna have a look at what the ray from the camera to the character looks like. So let's see if we can see that ray. All it is just a red ray from wherever the camera is to the character. We're going to be using that to figure out this distance. So we're zeroing out the y, and this rig to goal is going to basically give us the distance away that we need. So let's move on to the next step of the script. Next thing we want to do is we want to calculate the amount that we want to pan in and out. So that's going to be the idea of moving the camera inside of the rig. So we're just going to be moving in and out like this. We need to figure out the logic for that. So we'll go ahead and add a section right here for that. And I've commented this pretty heavily, and I'll give it an explanation too, just so it makes sense. The idea here is if the right stick is in the negative, so if we're panning backwards, we want to check and make sure that that's less than the previous frame, so that we know we're moving back further, so this value is less than it. And we want to also make sure that we've got this threshold value here. We want to make sure that the value is less than the threshold. And the reason for this is because if the value is, if this lerp function here, if you don't check this, then for some reason lerp doesn't really work with really, really small values of x. So if you held this down just slightly, it would kind of make those values a little bit funky. So the distance up, we want to calculate that by taking distance up and then the distance multiplier. So that's going to be, if we've got a distance away of 4 and the multiplier is 2, so we're going to move between 4 and 2. We want to make the distance free away basically be the same thing, but with the distance away multiplier. And we want to lerp between these values based on the intensity of how far you push back the y stick. The target position is then going to be as simple as calculating the same idea we've normally done. You take the follow transforms up vector, multiply it by the up scalar, and we take the direction to the goal, which is what we calculated here, that we normalize, and this is just a direction vector to the character. You want to multiply that by the distance away free. So let's have a look at what that does. And the same thing in the positive, and here it's a little bit different. The distance up, we're going to be lerping between the current distance up, so we just take the camera's distance minus the character's distance. So that's as simple as taking the vector from, I'll give you an example here. Here's the camera. We're just taking this distance, the height from here to this guy's height. So just subtracting these two heights. So we're just taking the distance up by doing that, and we're panning between that and the minimum distance that the height can be from the character. And for the free, we're doing the same thing, but with a minimum distance away from the character, which is the x value of that vector 2, and also we're taking the rig to goal's magnitude. And if you saw that red vector before, that gives us a convenient way of calculating the x value. So if you have a look at that, rig to goal dot magnitude is as simple as, let's see here. If you can see the red vector, right now we don't have target position set up correctly, so it's not really working. But if you can see that red vector that's shooting all over the place, that's the distance we need, the distance in x. Or it's really more like distance away. It's not really an x or y. So then we just do the same thing. We just set target position equal to the up times the up direction times the up scalar, and the away vector times the away scalar. So now we just want to smooth. We want to do a little bit of a condition check. Just for now, we're going to say we want to keep all of the camera free logic in one place just so we can debug it better. So we're just going to sort of quarantine it away from the rest of the code by setting these values away from to not compensate for the walls, and not to smooth the position, and not to look at the transform if we're in the free mode. And then the final thing we want to do in this method is we want to save the previous frames right x and right y values so that we can make these checks properly. So basically here, we want to use our own smooth position and our own look at. So we're going to smooth position between the transform's current position and the target position, just like normal. We're going to look at the character. So let's give this a shot and see if it looks like anything, or if we still have no behavior. So we still got some weirdness going on. Let's add in one more line of code. So if we don't set a target position, if one of these two methods doesn't get called, if neither one of those if statements is true, then when we set this to 0 up here, it's still going to be 0 down here, and then we can just set the target position equal to the previously set distance away and distance free. So hopefully now it'll work. Still nothing. So we're having a rough time of it here. Let's see. Oh yeah, we need to store the direction of the stick. So if we don't move in the X or Y stick at all, we just need to save the old direction. Okay, sorry about that delay right there. I had actually set the camera when I was trying to demonstrate. This is what I get for trying to do a demonstration. When I had set the camera height up here, this has started causing bugs because it no longer knew how to position the camera relative to the rig. So you definitely want to make sure that the camera is zeroed out. You need to make sure its transform is parented exactly to the parent rig, and that way our code works much better now. So we can zoom in, we can zoom out, we can rotate around the character, and we can move our character relative to the position of the camera, which is what we wanted. And all the pivoting and stuff still works, so this is exactly what we want. So let's have one more look at the code now that now that it's all in there, because this is one of the more complicated methods. What's happening here is that the way that we're doing this rotating around, you can see here the parent rig is set to rotate around the character offset, and this rotate around method is basically, it takes a point to rotate around and a degree, an axis to rotate about. So we want to rotate around the point of the character, so character offset. The axis we want to use is the character's up axis. We want to rotate based on the direction of the stick, whether it's moving right or left. We want to rotate in that direction some degrees per second. So that's what that's doing. And that gives you the effect of rotating that parent rig around the character. So here, if we zoom out, so we zoom out, you can see the parent rig is here. And if I hold to the left or right, the parent rig is rotating around the character. Inside of it is the camera, which is always facing down at the character. Because note the direction of the forward vector is pointing at the character, which makes sense because we had set the look at to be the character. So that's looking down here. But note that the camera rig is not using the look at. And again, the reason we had to use this rig is because we couldn't use this rotate around on the camera because it's already having its rotation manipulated by transform look at. So you can't manipulate the rotation twice, so we stuck it in that empty rig game object. So if you want to see the breakdown of the script, the panning in and out is handled by this section of the script right here. So this is panning in and out. And this section here is for rotating around. So that's about it. And the idea is that if we don't have any change in our panning, we just want to use the previous frame's distance away and distance free and set our target position that way. So that's pretty much, I think, all there is to this. I want to check one thing really fast. I want to see if we can combine this and get rid of this if statement, because that'll just make the code a little bit more orthogonal. So hopefully this will work. And we want to get that compensate for walls to handle this case too. Okay, cool. So it looks like it still works. And let's run over to a wall and make sure that the camera manages to push up against the wall. So you note if we just hold forward on the stick, the character runs forward. Hold right on the stick, he runs right. So that's what we wanted there. And I can rotate around and have the character adjust his positioning. And it looks like the compensate for walls works too. So we are all good there. And that does it for our camera rig. That one was probably the more intense one to write, so hopefully this code makes sense. It's a little hard to wrap your head around at first, but hopefully the explanation helps, and there's also comments as well. So thank you very much for tuning in for this last episode, and from here on out we'll be talking more about the character controller and mechanim code. Thank you.